Okay, guys? Zach? Okay, today we are doing, yes? Then you have to go back into settings and clear the cookies and all that stuff. Clear the history and the cookies.
Clear your history.
It's like this thing that like saves on the computer and like
Where's Safari?
Oh, I know what to do.
Right here.
I have no idea what a cookie is.
Cookies are ways that websites keep track of your visits there. Okay. Hey guys, focus. Girls. Zach. Cole. Okay, we're going to get going on this. We're going to do areas of triangles, trapezoids, kites, review the parallelogram, and the rectangle. Just real quickly. Okay.
Can I please go get a drink real quick?
Yeah.
Thank you.
Now, what I'm going to do is probably slightly different than what's on the bottom of the board. We should all know that the area of a triangle is 1/2 base times height. So what I'm going to do is really make a copy of this triangle and see why it's 1/2 base times height. Not a great copy, but it should work. Well, there we go. Okay, so we're grouping that. And then I'm going to rotate this over and slide this over. And what's true about my two triangles since I copied it? They are congruent, right? And they form a parallelogram. I only want, though, the triangle. So I only want this. Well, what's the area for a parallelogram? It's base times height. This is, I only want half of it. I don't want the whole thing. So you either can do this, or you can write it as 1/2 base times height, where I have it written right here. And that's why the formula is what it is. A triangle, Zach, is half of a parallelogram. If you understand why the formulas work, you tend to remember them better. So you should know a parallelogram, and if I look at my triangle, it's half of that. And then if you look at the bottom of the slide, there's a little presentation of why it's half. Personally, I like the way I do it with my little parallelogram, so that's all I'm going to do. So let's do some problems. I don't know why it's doing that, but that's okay. So some of you, when I looked at the homework, from the first hour class, they didn't show any work. You really need to show work. For one thing, you need to know what you did. And when you come back and look at it, and you say, well, how did I get that answer? So I write the formula down. It's 1/2 base times height, because sometimes I'm not going to give you the base and height. Sometimes I'm going to give you the area and ask you to find one of those. But in this case, I want the area. So it's 1/2. The base is 5 centimeters. I'm not going to put my units in until the end. And the height is 7 centimeters. So what's the area of that? This is not distributive property. We're going to do 5 times 7, which is 35. I don't care what half of 35 is, so I'll just leave it that way. 35 halves. And what are the units going to be? Centimeters squared. Now, how do you find the base and height? The base and height are connected by the little square. So it should have been a little square there. It's always the perpendicular. Now, the triangle's not always sitting on its base. But if it is, imagine dropping a rock. It's going to go straight down. It's not going to be that side. So it's going to be the perpendicular. So always look for the square. I don't know why it's doing that, but that's okay. So here's the square. Which sides are the base and heights? Doesn't matter which is which. 4 and 3, not the 5. The 5 is a hypotenuse. So the area is 1/2 base times height. And I find them because I find the square, and it's the two sides that make up that square. So it's 1/2. And the base is 4 centimeters, and the height is 3. So what's 4 times 3? 12. And you may use a calculator on all this. So the area is 6, and it's centimeters squared. Because what is area? Area is how many squares I can put in here. And unfortunately, that doesn't fit nicely there. It will fit nicely over here. So we have to do some estimations if you wanted to do that, or build a rectangle. Okay, is that okay for those triangles? Let's try some more. In this case, I'm given the area, and I want to find the base. Now, one of the problems with this is you think it's maybe sitting on the base. It's not. Well, it could be a base, but based on what I have in my diagram, it's not. The base and height are connected by the square. So this is the height to this side. That's the base that goes with that height. Yes, there are other heights and other bases, but in this particular case, it's right here. And if you want me to draw that picture, I can rotate it over. I'll try. Won't be a great picture. And I'm going to rotate it, and now it's sitting on the base. And there's the height. And this side is the base. So you have to be careful and make sure you look at the picture correctly. The triangle's not always sitting on the base with the given height. So I'm going to write the formula down. So area equals 1/2 base times height. Hopefully you're ahead of me. And I'm given that A equals 40. So where do I put the 40? I put it in for A, not the base or height. So just be careful. So 40 is equal to 1/2. Now, the base and height of this triangle, it's not sitting on the base and height. This is the base. That's the height that goes to that base. So it's 8 times B. Can I take half of 8? Well, I can. Can you guys take half of 8? Yes? No? It's 4. So then what do? We divide by 4. And how many times does 4 go into 40? 10. What are the units? Centimeters squared. And there were some hard problems on the first lesson. I did the packet and I put it up on Schoology. I don't know if you noticed it.
I don't think it's.
Oops. Oh, no, it's not squared. Sorry. Because this is the centimeters squared and this is the centimeters. So there's only one of them. So I'm left with centimeters. Not thinking. Is that okay? Okay, next time we're going to do a trapezoid. And again, I'm going to do my trapezoid different than what's on your slide.
Why is there a weird?
But I don't know, just for fun. It is kind of it's a optical illusion. I'm going to draw the diagonal here. I want to find the area of that trapezoid. And you could break it up. You could double it. That's one way to do it. Or I like this method. I have this triangle. Once I draw the diagonal, and I have this triangle. What's true about my two triangles? They're congruent, aren't they? No, they're not congruent, are they? Well, could I find the area of each one? What's the area of the yellow one? It's 1/2 its base, which is B1, and its height, which is H. What about the purple one? What's the area for this one? It's 1/2. What's its base? B2. What's true about the height for both of these? It's the same value. And so if I want the whole trapezoid, I'm going to add them up. So I have 1/2 B1H plus 1/2 B2H. And surprisingly enough, that is the same thing. You could distribute, or you could say, let's factor. What's common here? Remember greatest common factor? We're doing that right now in quadratic. What goes into both of these? 1/2. What else? H. If I factor those out, I'm going to pull out a 1/2 and an H. What am I left with? I'm left with a base 1. And I'm left with a base 2. If I just cover up the other ones. That's the same as that. You guys want to sit in different places? Okay. Now, when you look at this, if you take two numbers and divide by 2, what have you found? If I take 5 numbers and divide by 5, what have I found? Average. So guess what? This is the average of the two bases. So you could simply average the bases and then multiply by the height. Well, it's true in a parallelogram, but the bases are equal, if you think about it. And what is a trapezoid? Do you guys remember?
It is what's it?
Only one set of parallel sides, and there they are. You can go through this explanation of the trapezoid. I personally like this one. If you draw the diagonal, you find the area of the yellow triangle and the area of the purple triangle. It's going to work out for you. And if you forget the formula, because I think we're going to expect you to know this one, if you take calculus, you have to know this one. I just draw the diagonal and I figure it out every time. It's two triangles. So it's easier than you think. How about this one? I want to find the area of the trapezoid. So I'm going to write the formula first. Its area equals 1/2 sum of the bases, or you can put the height there, it doesn't matter. Because you're adding up two triangles. So this triangle is 1/2 base times height. The purple triangle is 1/2 base times height. If I add them together, I get this line right here. And if I factor out the common factors that I have in the yellow, I'm left with that. The 1/2 doesn't go away. Okay, so area is equal to 1/2. What's one of the bases? 11. The other base is 5. And the height is 7. And you can do this. Now I'm doing order of operations. What's 11 plus 5? 16. Half of 16 is 8 times 7. So this is what? 56 centimeters squared. Does this look familiar? You've done this stuff before, haven't you? No? Okay, let's look at this one. The formula is area equals, and there's room in my trapezoid to write it, so I'm going to write it there. 1/2 base 1 plus base 2 times the height. And when I do the homework, I'm going to write the formulas, and then I'll scan it. And you'll have all the work there, not just the answers. Okay, what do I know here? I know the area is 96. So what am I going to put in here for A? 96 equals 1/2, and then I'm going to add the bases. So it's 8 plus 16. To me, it's really clear as to what I'm doing, and I don't know the height. That's the question. So now you just need to solve for H. So 96 is 1/2 of, what's 8 plus 16? 24 times H. It's not distributive property. Some of you may think it is, but it isn't. So 96, what's half of 24? 12 times H, and then we'll divide by 12. Do you guys know how many times it goes in? Well, 12 is pretty close to 10, isn't it? And 10 would go in about 9 times. But it's a little bit bigger than 10. So I'm going to guess 8, and it is 8. So I can use some estimation to figure it out if I don't have my calculator handy, which I don't. Is that okay? One more shape. A kite. What's a kite? No, it's not a rhombus. A rhombus is a kite, but a kite is not necessarily a rhombus. It's a quadrilateral with two, nothing parallel, two consecutive pairs of segments or sides congruent. So what I'm going to do here is I'm going to find the area of this triangle, because I can, and that is, for the yellow triangle, it's 1/2 base times height. What's the base of my yellow triangle? It's this length, which is the length of what? Yeah, what's it called? Because it's a diagonal. So it's one diagonal. What's the height of this little triangle? What's the height here? Because we know the diagonals are perpendicular, right? D2. Now that's just for the yellow triangle. That's just this one. What's true about this one? Oh, wait, is it just D2 or is it only half of that? What's this height here? It's not D2. D2 is the whole thing. So it's what? D2 over 2. Now that's the area for the yellow one. What's true about the yellow one, and I'm going to make it a green one? What's true about these two areas? What's true about those two triangles? They're congruent. You guys need to sit someplace else?
No.
These two are congruent, so if I want the whole kite, what do I have to do to my formula?
So, multiply 2.
Multiply by 2. So I'm going to have 2 times 1/2 d1 d2 over 2. What happens to these 2's?
They turn off.
They cancel out. So the area for the kite is d1 times d2 over 2, or 1/2 the product of the diagonals. I tend to remember it that way. It's 1/2 the product of the diagonals.
So why do we have to show that before?
I'm showing you why the formula is what it is. So I found the area of the top triangle, and I doubled it to get the kite, because these two triangles are the same. Remember, these angles are congruent. And you remember these angles here are congruent. I've got a lot of stuff that's congruent. Now, we don't know how to prove triangles congruent, but that, believe me, that's enough to know these two are the same. They look the same. So to find the area of a kite, you just find the length of the diagonals and divide by 2. It gets harder when we get to right triangles in here. So we're going to use this all year. And there's the explanation. So let's do some problems. So I write the formula down. And then if you get it wrong, if you write the formula down, at least I can figure out what you did wrong. So part of this is not just getting the right answer, but communicating. So it's 1/2 d1 d2. What's one diagonal? Now it's this whole length. Zach, how big is that? 14. Good. And what's the other diagonal? Cole? No, the whole diagonal. It's 6. Now, do you want to do half of 14 before you multiply by 6? Because that would be easier?
Yeah.
Well, it's easier for me. Because I don't have a calculator. So 2 goes into 2 once. 2 goes into 14 7 times. So the area is 7 times 6, or 7 times 6 is what? 42 centimeters, because we're finding area, squared.
So we only,
Both what?
so we only take 1/2.
It's the product of the two diagonals. So it's 6 times 14, and you divide it in half.
I got the same answer, but
The order in which you do this doesn't matter.
I found to see if this was right. I did in parentheses. I just did 1/2 times 3.
Oh, you could do 3 times 14 plus 1/2 of 3 times, do I have that right? It's 1/2 base times the height of 14. Yeah, you get the same thing.
No, but I did 1/2 times 3 times 14 in parentheses, and then once I got that, I got 21/30 to it, and I multiplied it by 2.5.
Yeah.
So is that
Yeah, that's okay. So you could break this into, you could even break it into 4 triangles if you really wanted to. Or you could you broke it into 2 triangles. I actually did 1 triangle and doubled it. It's the same as the formula. It doesn't matter, as long as your process is correct. So this one's a little different. This one is, the area is 140, so area equals 1/2 d1 d2. So I'm going to put the 140 in where? Or A. 140 is 1/2. Do I know the long diagonal? No, I don't. That's A to C. Can I call that D1? You can call it AC if you want. I don't care. What's D2? 14. Yeah, there's more ways to do this. This is the most efficient way. Can I go ahead and do 1/2 of 14? Is that okay? Yeah. It's not distributive property. I can switch the D1 and the 1/2 if I want, or I can just plain do it. So it's 7 times D1, and then what do? Divide by 7. So D1 equals, no, not 10, 20 centimeters. Okay? So we did 3 things. First we did triangles. That was, well, that's a lot. I want a triangle. I don't want that triangle. I want any old triangle. There we go. There we go. We did triangles. Let's just review it. Here's the base. Here's the height. And we really need that little square. And it's 1/2 base times height. Now, the ones with the perimeters, you may have to do some work on it. Let's see, next one was a trapezoid, right? And a trapezoid is made up of 2 triangles. Sorry. Okay? So this is base 1, this is base 2, and there's your height. The height is the distance between the bases. So the area, label a trapezoid. And you can always break it into 2 triangles. That's why I show you that. If you forget the formula, just break it into 2 triangles. It's 1/2 the sum of the bases times the height. And then we did a kite. And a kite's going to be hard. Maybe I'll just draw it freehand. Because there isn't one then. These are congruent. These are congruent. If I draw in my diagonals, that's D1. That's D2. Okay, guys? It's 1/2 D1 times D2. And again, as some people did, they broke it into triangles. But there were 2 other figures we did yesterday. We did 2 other figures. Tomorrow we're going to do a polygon. And yesterday we did a rectangle. Remember that? And that was pretty easy. What's the area of a rectangle? Now, the problem is, I could bring it into triangles, but that's the reason why the area is what it is, how many squares fit in there. And then we have a parallelogram. Guys, we're almost done. Okay, TJ, what's the area of a parallelogram?
Base times height.
Base times height.
Quadrilateral.
Okay, but tomorrow we're going to do polygons.
Oh.
And I don't think you've seen that one. So there they all are. Yeah, we have homework. We're doing lesson 2 in your packet. I'm going to answer questions on lesson 1. Because there may be questions. Now, I did put my answers on, and I don't know for a fact that my very last one is correct. I know the first page and the second page are correct. We had questions on number 11. You should have your yellow packet out, because I'm going to check it off to see that you did it. And by the way, all the work I show is really the work you should be showing as well. So I got a lot of answers on number 5 without units. You need units in there. But without any work. And, if I just gave you the answer to number 5 is 91, and you don't know how to do it, that's not going to do you any good. But you should be able to look at my work and figure out how to do it. And if not, then you come in and get extra help and ask questions. So do we need to do number 11?
No.
We got number 11. Answer to 11 is 57. Find the area of all the triangles.
Oh, yeah.
There's a variety of ways to do it. How about number 12? Oh, 12 I thought was tricky. How many tiles did you get?
I got 56 tiles.
Nope. Okay, so we're going to look at number 12. Now, we're only going to tile a wall. And I've also had a sneak peek at the test. You have to be able to do this painting or tiling.
No, because
It's a wall. Yes, but watch your units. It's 4 feet by 7 feet. Okay, so there's 4 feet. There's 7 feet. Well, let's first find the area. What's the square footage here? It's base times height. So it's 4 feet times 7 feet. Is that clear how I'm going to get 28 now? Square feet. Okay, here, y times 2. We're only doing one wall.
no, because the number of tiles are 6 inches instead of a foot.
That's right, but you have to talk about square feet. Let's draw the picture. This is one tile. That is 6 inches by 6 inches, or 1/2 of a foot. And that's 1/2 of a foot. So what's the area for one tile? It's 1/2 times 1/2, or 1/4 of a square foot. It's not half. Common mistake. So it's going to be 4 times 28. But I think there's an easier way to look at this. What I did was I took this and I said, well, this is 1 foot. This won't work if it's not 6 inches. But here's a tile. That's 6 inches. And this is a foot. This is a square foot. That's 6 inches. This is 6 inches. That's 6. That's 6. But what is the area here? If this is 1 foot by 1 foot, this is 1 square foot. How many tiles give me 1 square foot? Look at the picture. 1, 2, 3, 4. So for every 1 square foot, there are 4 tiles. That's why it's 4 times 28. Yes. So you should get 112. And answer only will not work. Because the units are not feet. The units have to be the same. I either change that to square inches or I change that to square feet. They have to be the same. So since the 6 inches is 1/2 of a foot, I can put a tile here and a tile here. That gives me 1 foot on this side. And if I put a tile here and I put another tile here, that gives me another foot on the other side. So a square foot contains 4 tiles, not 2. That's why they're called squares, because this makes up a square 1 by 1. So I thought that was kind of tricky, number 12. 13, I got 96, just base times height. How do you find the height? Go to the top of that parallelogram and drop a rock. It drops 16 squares. And then on 14, if you just have my answer without any work, then I know you just copied it. And I'm not even sure I'm right. And 15, I'm still not sure I'm right, because I had to do a lot of thinking on 15. Because I know the roll's 50 feet long, so I can cut that into strips. So I'll leave them up. We can talk about them. I'd like to check them with the other math teachers to see if they got the same answers I did. But we can leave that up, and then you are to work on this one. I'm going to come around and mark off your assignment today.